Here's the next question, number 39. In the circuit shown, switch S2 has been closed for a long time. At time t is equal to 0, switch S1 is closed. At t is equal to 0 plus, the rate of change of current through the inductor in amperes per second is dash. So this is not a multiple choice question, we will have to work it out. We have been given the circuit with two switches, S1 and S2. Now the question says that S2 has been closed for a long time, and at time t is equal to 0, switch S1 is closed. T is equal to 0 plus indicates the time right after the switch is closed. So in this case, we will have to consider two instances. We will have to consider the circuit at t is equal to 0 minus and at the instant t is equal to 0 plus. The instant right before the switch is closed and the instant after the switch is closed. Okay, so when t is equal to 0 minus, let's look at this. When t is equal to 0 minus, S1 is not closed. S1 is not closed, it's open. So when it is open, we will have to consider just this loop over here, this part of the circuit. So I'll write this here. At t is equal to 0 minus, the circuit is this. Now switch S2 is already closed, so you can consider this as a closed loop entirely. Okay, so this is for the instant right before the switch is closed. Now here, the current that is passing through this inductor is the same as the current that is passing through this branch over here. Now because these two are connected in parallel, so we can write this as the current passing through the inductor at t is equal to 0 minus would be the current that is passing through this branch over here. So we can write this as, we know the formula, the basic formula by Ohm's law, V by R. So that's 3 divided by 2, which equates to 1.5 amps. So this is the current, the inductor current at this instant, at t is equal to 0 minus. Now the next thing we have to do is find out at t is equal to 0 plus. Let's evaluate. I'll write this over here. T is equal to 0 plus. Now t is equal to 0 plus, the switch S1 is closed. Now when switch S1 is closed, we have the entire circuit to consider. So we now have, just a quick moment. And the inductor here. Okay, so this is what we have where both S1 and S2 are closed. This is 3 volts, this is 1 ohm, 1 Henry, 2 ohms and 3 volts. So we need to calculate first the voltage at this point. Let's consider this as VA. The voltage at this point, at this node is VA. So let's write the nodal equation. The nodal equation would be VA minus 3. Now we're looking at this branch over here. So VA minus 3 divided by the resistor between them, which is 1, plus, now we're going to look at this part. So this is VA minus 3 divided by 2. VA minus 3 divided by 2. Plus we have the voltage over here. So that's VA minus 0 because this is 0 potential. So it would be VA divided by, we already have the current in this branch here. We have found that to be 3 by 2. So this is 3 by 2 is equal to 0. So we have 3 parts in this nodal equation. VA minus 3 divided by 1, VA minus 3 divided by 2, plus the current through this branch over here, which is 3 by 2 is equal to 0. We equate the entire equation to 0. Now let's solve VA from this equation over here. So we can write this as 2 into VA minus 3 plus VA minus 3 plus 3 is equal to 0. Okay, let's expand. That's 2 VA minus 3 plus VA is equal to 0. And that's 3 VA, oh I'm sorry, this is 6. 2 times 3 is 6. So 3 VA is equal to 6. And that gives us VA is equal to 2 volts. So the potential at this node over here is 2 V, 2 volts. Let me just grab another piece of paper here. Alright. Now we have the voltage at the node as 2 volts. Now you have to recall the voltage equation of an inductor. So we have V is equal to L di by dt. I'm sure you're very familiar with this. Now if we are considering at that particular point, at the instant t is equal to 0 plus, because that's the instant that the question is asking us to find. At t is equal to 0 plus, the rate of change of current, that is this di by dt, rate of change of current through the inductor. Okay, so I'll write that. Now this equation, to be more precise, it is VA is equal to L di at 0 plus divided by dt. Okay. Now VA is already, we have found what VA is. VA is 2. So if we substitute that over here, we have 2 is equal to L di by dt. So di by dt is equal to 2 divided by L. From the circuit, we have the value of L given to us as 1 Henry. So we substitute that value here. So that's 2 divided by 1, which is 2. So the rate of change of current at 0 plus, at time 0 plus, is 2 ampere per second. So this is the final answer, is 2. I hope this has helped.